Hello everybody, Mr. Hanson again. Today we're going to look at a topic called simplifying expressions. So what I want to do today is just look at some examples, see if we can come up with some general rules on simplifying. So here's problem one. We have an expression 4x plus, and I'll use a different color here, 8 plus 9. Okay, and the directions of the problem are to simplify it as far as we can go. Well, what I did is I highlighted what are called like terms in the same color. So constants, numbers with no variables, are like terms. You can add them together. But we can't combine it with something with a variable on it. For example, 4x. Okay, because if you remember, order of operations says we multiply before we add. Well, if we don't know what x is, we got to hang on to this operation, multiplication operation, until we know what x is. So the best we can do for simplifying is combine the two constants together and simplify it to the expression 4x plus 17. We cannot combine 4x and 17. They're unlike terms. Okay? Let's look at another example. How about if we have 6 plus 3 times the quantity of 4x plus 5? And again, our goal is to simplify the expression. Well, last unit, or last section of the chapter, we talked about different properties of real numbers. And one of the properties was distribution. Can you identify in this problem where we might want to distribute? Well, if you said here with the 3, we distribute the 3 through the groupings to the 4x term and the 5 term, we've done our job. So let's just write this below. We get 6 plus, now for 3 times 4x. Now, if you can multiply constants together even though they might not be like terms, because this is called a multiplier or a scalar. Okay? So 3 times 4, we can write that as 12x. Okay, 3 times 5 is positive 15. Okay, are we done simplifying? Are there any terms that are alike? And the answer is yes. The constants, again, can be combined. So our final answer would be 12x plus 21. And because 12x is not the same kind of term, same variable term as the constant 21, this is all the farther we can go with our simplifying. Okay? Alright. So let me just define a term. A term, let me remove this up for you. A term is a number, I'll abbreviate when I can, a variable, or a product. Remember, product means the result of multiplication. Or quotient, remember that means the result of a division problem of numbers and variables raised to powers. Now notice the key thing here for the definition of a term is it doesn't talk about adding and subtracting. So the addition sign and the subtraction sign are what separates terms, and sometimes it's easier to think of it that way. For example, if I had 9x plus 15y squared, the terms in this problem would be 9x. Okay, see there's a product, there's a variable, there's a constant. Okay, it's separated by an addition sign. And a second term, so this would be the first term, this would be the second term, and the terms are separated by addition or subtraction. Okay? So, we'll talk more about terms as we go along with other examples here. Alright, new sheet. Alright, so we're still talking about simplifying expressions, and let's combine like terms here. Let's say we have an example We want to combine like terms. Combine like terms. So let's take a look at 6r plus 3r minus 5r. Well, one analogy we could use for what like terms are, I always call them the numbers with the same backpack. If you think of a number here as a person, the same backpack, what I mean by that is they have the same variable attached. So the backpack for 6 would be r. 3 has a backpack on, that backpack is r, and -5 has a backpack of r. And if all three terms have the same backpack, or any terms have the same backpack, the rule is you can combine them. Okay, so 6 plus 3 is 9. 9 minus 5 is 4r. Okay. The reason you can do that is technically you're pulling out a greatest common factor. They all have an r in them, right? So if I pull that out front, we're left with 6 plus 3 minus 5. If you do the arithmetic, 6 plus 3 is 9, take away 5 is 4. So that's another way to think of it. That's why you can combine like terms, basically. Okay, let's do one more. Let's combine all possible like terms with this problem, 14y plus 2 times the quantity of 6 plus 3y. Okay, again, we're going to have to do all the simplifying tricks first. In this case, I think you all see that we have to distribute our 2 first. So let's write the next step. This equals 14y. And by the way, this is the kind of work I would expect to see in your homework. 14y plus 12 plus 6y. Now take a look at these three terms. Which numbers have the same backpack? Well, it'll be this and this, right? They both have a y. 12 doesn't have a backpack, so it's kind of excluded from this club anyway. So 14y plus 6y is 20y plus our constant 12. Typically, when we write the answer, we'll try to put the constant last. Okay, but it would not technically be wrong if you wrote 12 plus 20y. Okay. Let's take a look at one more example. Now, let's do a translation problem where you have to translate a sentence into a mathematical expression. Okay, and so what we'll do is we'll translate this example and then we'll combine like terms. So 5, here's the problem. 5 times a number added to the sum of the number and 3. 5 times a number added to the sum of the number and 3. So let's see if we can translate this verbal sentence. So 5 times a number. So let's use x for our number. Added to the sum. So 5 times a number added to the sum. So we're going to add 2 more things. We're going to need parentheses of the number and 3. Okay, let's just make sure you understand this. 5 times a number added to the sum, remember sum means add, the number and 3. Now since there's no number out here to distribute, we can drop these parentheses. So we'll have x plus 3 plus 5x. Okay, and remember the coefficient, if you don't see one on an x, technically there's a 1 there. Now standard practice, we don't write the 1, but it does exist there. So these are called coefficients. Oops, I'm sorry. The numbers in front of a variable are called coefficients. So we want to add coefficients of like terms. That's the rule. Okay, so if you look at this problem, I have a 1x and a 5x. They have the same backpack, so they're like terms. So that sum is 6x. And then we have the constant term of 3. So that would be our simplified version of that expression. Hopefully that helps with some of the simplifying expressions, and we will work on some problems tomorrow. Have a great night.